All right, we'll get started here, and we have a jam-packed session. This is Coding for Fun, build fun, cool, commercial applications using the Kinect for Windows SDK. I'm Dan Fernandez. My team does Coding for Fun in Channel 9, so a lot of the live stream that you all have been watching is us, and we do fun, crazy projects like building boxing robots. We've been using the Kinect since, let's see, Kinect for Windows SDK, the first beta. I actually wrote the first spec on the managed API and have been tinkering with it since. To my left is...
Hi, I'm Rick Barraza. I work for Dan in the Coding for Fun group. We also have Clint Rutkus up there in the green shirt.
Yeah.
And Brian Peak is the last member of the team who couldn't be with us today, but we're usually the ones responsible for whatever things you're seeing here.
Exactly. So this is going to be a fun session just to give you kind of high level what we're going to be doing. We'll talk about the Kinect sensor. And how many of you have actually built an application with the Kinect or have done Kinect programming? Okay, the majority of you haven't. I think hopefully we'll be able to show some stuff that maybe you all that have used Kinect haven't played with before. Things like maybe face tracking, Kinect Studio, and so on. For those of you that haven't, we're going to take a deep dive and sort of move slow in the beginning on image processing and some of the details there, and then show some more fun demos and build up into having boxing robots. And we'll actually ask for 2 volunteers who will play for a Kinect for Windows sensor. Hey. And you all will cheer them on, and it'll be wonderful.
Oh, Dan, on the level setting, how many of you here have done any type of image processing either in WPF or C++? That's another kind of level set.
Okay,
so some of our demos early on will be dealing specifically with that, which is...
It'll be a recap, but what we want to do is make sure, because we are dealing with Kinect and it is a camera, that you understand the basics of how to handle an image processing. Because that's what the Kinect API returns, and there are some helpers to make that easier for you. But we want you to have a deep understanding. And the idea here is, if in your company you start thinking about applications, maybe it's a way to visualize reporting data using Kinect, that you get to be picked as the person that actually knows Kinect and be able to build the fun applications. And you can say that by having attended this session. And I'll vouch for you.
From Hello World image processing to killer robots in 60 minutes or less. That's what we're going
75.
For. 75.
75. OK, let's get to it. All right, so level set. Kinect is 2 things. People do get confused by this. It's hardware and software. And in fact, we released a type of hardware called the Kinect for Windows sensor. The difference is the word Kinect here and the fact that it has near mode. So near mode allows you to actually get data from the Kinect, including skeletal data, from 0.4 meters away. So it's an important distinction. The feature for near mode is only in Kinect for Windows. And if you're building commercial applications, let's say, for example, you're working for a retail store, and they want to have something where they have an interactive display, maybe something that draws clothing on, you do need a Kinect for Windows sensor because that's the way that it's licensed. The Kinect for Windows sensor, however, cannot play Xbox games. So it cannot play Xbox games. If you want to play Xbox games and develop and test, get the Kinect for Xbox 360. All of the demos I'm going to show you, because I'm not showing near mode in a demo, will work with the Kinect for Xbox 360, and we're just going to be using C# Express. Yep. So in terms of software, there is the Kinect for Windows runtime, and this is the low level. Think of it as, if you're familiar with the .NET framework, this isn't the .NET Framework SDK, it's the .NET Framework. It's the runtime. It's just what's needed to run applications. The equivalent of the .NET Framework SDK is the Kinect for Windows SDK. And that includes things for application developers. So one is a runtime to run your applications. The other is SDK, things that you would use to build an application. And on top of that is the developer toolkit. And that's actually revving a lot faster. And we assume the API is stable, and now we're going to build things on top of it. So you, the Windows SDK, give me color depth skeletal tracking. I will then add APIs that take that data and do things like face tracking, and so on. OK, so for the Kinect sensor, and I just want to go through this very quickly, is the way the magic of the Kinect, if you will, works by having an IR emitter. And what that does is it actually sprays a known pattern. A known pattern sprays out, and using the IR depth sensor, we look at that pattern. Since we know how that pattern is laid out, distortions of that pattern we can measure and turn into depth data. So again, it shoots at that pattern. We return it. We analyze that data and look for distortions in that known field. And from that, we can actually determine depth. There's a color sensor, and that's a camera that fires at 640 by 480, just a regular RGB camera. And there's a microphone array that Rick is going to talk about.
Yeah, again, highlighting it is an array. A lot of times when we're talking on Kinect, there's so much focus on the fact that it's returning depth data and what you can do with that. It also has a very, very powerful set of audio functions, and we'll be going into detail to expose those today, but hopefully we'd love to see more of those exercises from the community as well. It's a underused feature, and we'd love to see it get the attention it deserves.
Now, one thing to keep in mind is this is all traveling via USB. And what's going over USB is a series of bytes that represent the color camera and the depth camera. So when we talk about skeletal tracking, that is not coming through this USB cord. That is actually processed on a PC. And we'll talk about and show how you can do skeletal tracking easily in your applications. OK. So when we were talking about the Kinect camera angles, one thing to keep in mind, this is just the field of view, is you can programmatically control the tilt. And what that allows you to do is do plus or minus 27 degrees up or down. It isn't designed to be a fast tilt. So if you're looking to do something quickly, that's not what the motor's for. The API will actually shut you off if you send too many tilt commands. But just realize that you can do things like, say, for example, if you've played Xbox before, where it'll scan the room for the first time and figure out what the best angle is based on its position. OK, so let's start talking about the API. The first thing we're going to do is manage Kinect state. And what that means is we can pull up how many Kinects are connected into our PC. And you can have up to 4 Kinects on one PC. Now, there are a couple limitations here. One is if you're plugging in 4, you need 4 USB controllers. You need a USB controller per Kinect. So you can imagine having a big tower. You'd need 4 USB controllers for each Kinect. And then to do skeletal tracking, specifically skeletal tracking, you will need a separate process. Meaning, if I have an application that has skeletal tracking, I need to open up 4 instances of that application to get skeletal tracking. And that would be the maximum. And then you can have 8 skeletons tracked and pointed different ways. Now, if you have multiple PCs, you can, of course, combine all this data because it's just data. We can record and do interesting things like some of the applications that have done 3D modeling by having, say, 4 Kinects pointed in one direction. So once we know the state of our Kinect, we enable specific features. And I say, literally, I say enable, and I can pass in parameters for what I want to enable. I start the Kinect streams. And then to get data, there's 2 ways. I call all frames ready, or the specific type of camera. So color frame ready, depth frame ready, skeleton frame ready. I would suggest you use all frames ready. And the reason why is what that does is actually synchronizes the color, depth, and skeleton into one handy package. And the reason you want synchronization is, for example, if I want to draw something on a skeleton position on a color camera so it looks like somebody's holding an object in their hand, I want them to be in sync so I'm not firing, say, 200 milliseconds off and it doesn't appear to be in sync. So by getting all frames ready, you make sure all frames are in sync. And that event will fire 30 frames per second. And then polling. So if you build X and A applications where you have more of a game loop, and Rick will show you an example, that's open next frame, and I'm just reading that at 30 frames per second. Yeah,
so in day-to-day use, basically, it would be if it's C#, WPF, that's an event-based model, so all frames ready is what you want. If you're XNA or C++, open next frame is going to be your best friend.
OK, so image processing 101. This is the part that we all just have to make sure to get on the same page to make sure you're not confused by what's actually going over the wire. So the API exposes this data to us, and we have some helpers that are going to make your life a lot easier. So one is the format of the data is BGR32, and that's blue, green, red. So if you see here, what we're visually representing is 2 pixels, 0, 0, and 0, 1. And the values are 0 to 255, 0 to 255, 0 to 255, and empty. That's always going to be 0. So BGR32, and you'll be able to count pixels. So if you wanted to know what the color is, that's all 255s, which I believe is white.
Yeah. And this is the image that the Kinect is returning to, right? A lot of images are done in different ways. These pixels specifically 32 bytes.
Yeah, there's a number of different formats. This is what the Kinect uses. And this is what we're going to take these bytes and actually make an image out of. OK, so the Kinect image sizes, The color camera is for 30 frames per second. It only has one resolution that fires 30 frames per second, and that's 640 by 480. The depth camera has 80 by 60, 320 by 240, and 640 by 480. Now, the one thing I do want to explain is, since we're taking these bytes into an image, we need to, for this image to exist, the .NET classes to build images, and specifically we're going to be using a writable bitmap, requires something called stride. So if you haven't done image processing before, what stride is tell me the number of bytes I need to assign to a single line on an image. So for example, in a 320 by 240 image, I need the width, which is 320, times the number of bytes. So since it's 320, each pixel 0, 0 is going to have 4 bytes, 0, 1 is going to have 4. So really the formula is just 320 times 4. Because 0, 0 is going to have 4 pixels, and every pixel in that line is going to have 4 pixels, blue, green, red, empty. So now you've learned a new term. You can put it on your CV. I know how to do image processing. This is, I know what stride means, et cetera, et cetera. OK, we've talked too much. We've got to get into some demos. So the first demo I'm going to show is camera fundamentals. So I have Kinect installed. And let me zoom in here. When you install the Kinect SDK, you want to reference a Microsoft.Kinect library. And also included in the developer toolkit, now this is in the developer toolkit, not in the SDK, is the Microsoft.samples.Kinect.wpf viewers. And these are tools that actually take the process out of having to worry about image processing for you. So I'm going to show those first to show you the easy way to the hello world, if you will, and then we'll show some of the differences. So in the toolbox, by having this in my project, I can just drag and drop, and you'll see that there's a number of viewers. I'm just going to choose the color viewer and the depth viewer. And we'll select both those images because I just want to change the width here, and we'll zoom in. Width of 320 and height of 240.
Now, you're doing that so that there's no additional stretching. They could be any width and height you wanted, and you adjust the stretching, but this is the default size you'll be registering into.
Yeah, I'm just making it so we can easily see it, and it fits in this size image. All right, so I'm going to go to the code behind, and notice we do have references to our two usings that we're going to use, and nothing special. We're going to start in here. And people in the back, can you all read this code? OK, wonderful. If not, feel free to scream. So I'm going to full screen this. And the first thing we're going to do is create a Kinect sensor. Sensor equals. And we're going to hard code this, and I'll show you ways that you can be a little smarter on this for more reliable applications. But right now, I'm just going to default and say I only want the first sensor. So I can pull Kinect sensors, pull up the first sensor, and you can imagine, say, if there were 2 Kinects, I can choose the first one is for this, the second one is for this, and so on.
This is the most common actual use case, though, because most people are working on apps that only have one Kinect plugged in. But.
OK, so Kinect Sensor Manager is another class. And this creates a WPF-friendly bindable version. And that's also what the WPF viewers require. The WPF viewers require the creation of the Kinect Sensor Manager to get Kinect data. So I am going to do that real quick and say Kinect Sensor Manager. And that has one property called tell me what Kinect sensor this maps to. And that's sensor. Now, we've created 2 of those, Kinect Depth Viewer 1, .Kinect Sensor Manager equals manager, and Kinect Color Viewer 1, same exact line of code, manager. OK, so recap, start with the first Kinect, create a manager class, and then set the 2 properties for those. Let's see what that looks like. Any luck? OK, so on the left side is the regular color viewer. On the right side is something that actually, and we can see some of the depth data. This is actually about the area where it doesn't know where the distance is. And right there is what's called unknown. And we'll talk about some of these distances when we get into the depth camera. But the point is, I wrote 4 lines of code, and I'm looking at data from Kinect. Easy to use these WPF visualizers. Make sure to use them in your applications. Now what I want to do is, since they were easy, I want to talk about the simplest way that we can reuse them in our applications, because you are going to need to get into this data. So to do that, first, we're going to kill our easy mode. And we will delete all the sensor manager's code because we don't need it since we're not using those WPF viewers. And I have just a code snippets file here. And I'm going to copy paste a couple things and then we'll talk about it. So it's full screen or copy paste.
And again, so the first thing Dan showed was if you're dropping two components on screen, you don't want to handle, you don't want to deal with image processing. That's fine. If you really want to start getting into the data and doing fun and unique things, if you want to be coding for fun or for work, you do need to start getting your hands dirty with the bytes in the image. And that's the next step up that we're doing.
Yeah, so for this one, what we're going to do is show, because we are getting that RGB empty, how do we actually take that data that the API gives us and turn it into an image with code? So the 4 things we need. We have to have the image size, the color data. This is the container of data that the API actually returns from us. We will have an array of bytes. The first one will be the red, the green, blue, empty. Second, red, green, blue, empty, and so on. The stride, which we all know, is how many bytes per line. And then what we're writing to. And we're using a writable bitmap because writable bitmap is designed that we write a bunch of bytes into it and then we clear it out. Write a bunch of bytes into it and clear it out. If we were building a regular bitmap or image every time, it's actually bad for performance. The one that's really optimized for performance is a writable bitmap. And again, this should be review for most people that have done image processing, but for everybody else. OK, so same thing. We build our sensor. We're going to enable the color stream. Now notice we didn't do this in our Kinect color viewers or the Kinect depth viewer. And the reason why is because those controls, they have a reference to the Kinect, so they can turn it on. They can sign up, register for events, and so on. We set our image size is going to be 0, 0 to the width and height of the color stream. So whatever the width and height of the color stream is, which we are setting here, 640 by 480. So now we know the image size, and then our width times 4. And now we can actually also ask how many bytes are included in this image, and that's the pixel data length. And now we're going to create a writable bitmap first, passing in dots per inch in the pixel formats. And this we need to set is the BGR32. And we lock on the source once. Now, we've built an image, but now we need to update it every time. And we're going to sign up for that all frames ready. And make sure to turn on your sensor to actually start receiving images. So all frames ready. And this is just important. The API works consistently with events. What that means is whether we're using color, image, or skeleton processing, you're going to have the same pattern. One is because this is a 30 frames per second, we have to be really careful in terms of what we do in this frame and disposing of objects. So make sure to use a using statement. So that way when this color image frame is done, the next frame, we can actually drop it. Remember, it's 30 frames per second. Another thing we have to watch out for is the color frame. It will be null sometimes. And the reason it can be null is, let's say, for example, somebody's running an application and something else happens to take up a ton of CPU. It can actually say somebody starts playing Diablo. Any Diablo players? Yeah. Oh, yeah. All right, my people. Thank you. You will start dropping frames. And the reason why is from a performance perspective. What we don't want to do is from an API is give you an old frame. Because you imagine that happens a lot, then your application's actually out of sync. We'd rather drop that frame and give you the most immediate correct data. So make sure to check for that. And now we copy pixel data too. And what that basically does is we have our color frame, write all of the bytes for that frame into our container, and the color data is our container, and then we use the right pixels and pass that in. So, and color bitmap is just our writable bitmap. And there should be nothing new here in terms of this working, but now we have a wonderful image. And this one's a lot bigger.
Now, on the XAML side of things, you had dropped an image control and then set it to point to that color bitmap, correct?
Yes.
Okay. It went really fast, so I want to make sure that people saw that.
Yes.
Okay.
Okay, sorry. So you have lived through the most boring demo that
really
we were going to do,
was.
but now you can add image processing and just know the kinds of data that are in there. And again, use those WPF viewers when you can. They'll make your life a lot easier. Now we're going to talk about depth data. Always fun. So the difference between the depth camera, a color camera returns what it sees. A depth camera returns the distance and player index. By distance, I can tell, what the camera does is says, I can tell you the distance of every pixel. 320 by 240, this is the distance from the Kinect for that pixel, for every pixel. So 76,800 pixels of distance and player index. And what we mean by player index is I can tell you whether it's a specific person, whether it makes up a specific person. And we do need to enable the skeleton stream to do that. The distance, by the way, is measured in 2,000 in millimeters. So 2,000 millimeters, or about 2 meters away from the Kinect, would be an example distance. The player index, it can tell you up to 6 people, for example. And the way this is actually laid out is a 16-bit short. So if we were to look at the memory of that specific short, this is what it would look like, the last 3 representing a player index. So in terms of Kinect, when we talk about default and near mode, we have added near mode, and again, only available for the Kinect. What that allows you to do is get the distance from what used to be 0.8 meters to now 0.4 meters away from the computer. And 0.4 is actually pretty close, which is 1.3 feet. You can be pretty close from your PC. In fact, you probably don't want to be anywhere closer and get the full features of Kinect. But that also comes with restricting moving the maximum distance to 3 meters. Versus the default mode, if you don't actually set this in the API, the default will be 4 meters max distance. Now, what you see, though, is that unknown was pretty large when we started the Kinect beta. And what we wanted to do is give developers more information such that they can actually tell end users to say move forward or backwards. So we added the ability to have too near and too far. So what these allow you to do is if somebody gets beyond 4 meters, you can tell the end user, we know you are too far away, move closer to the Kinect, and they can move in. Similarly, if they're too close to the Kinect, we know that distance. Now, there will be some distances that are unknown for whatever reason, and you can see those, and they maintain the color. OK. Now, the API is going to return to us an array of shorts. And those shorts represent that distance data. So what's odd to us, though, is we're working in an X and Y, a 320 by 240, but now it's a single-dimensional array. So if you need to play with this data, and maybe for your application, for example, one cool application that I heard recently was a UK company that's using this for using raw depth data to actually connect up satellites in space. They're going to actually have Connect in space, which is nice. That should be our next project. But by doing this, what they would need to do is, in building the application, is look at this raw depth data. For your application, you may not, and we'll talk about some of the skeleton applications you won't. But what they need to do, for example, is start off with a single dimensional of short data, and then use a couple of these formulas to be able to figure that out. So if I wanted to get the depth for a specific point, it's 160 by 120, for example. Then I use the int index equals width times y plus x. And again, you can reference these formulas. The 2 formulas I want to talk about, though, are how to actually get that distance. Since we know it's a 16-bit short, we need to do a little bit of bit shifting here. So we're actually going to do depth point and bit shift by the player index bit mask width to get the depth. And for the player formula, we use an and on the depth point to be able to get that out. And what we're doing is, again, reading values from there and using bit shifting to get those 2 different values. OK, so let's show some depth samples. We will open up our working with depth data. And what I want to do is visualize depth data. And the way I'm going to visualize depth data is by saying, if you're at a certain distance, I'm going to color the screen one color, another distance, another color, and so on. So before we get started on that, I want to show another option for using a Kinect sensor. And that's using, one is we have a UI control. So if you want to tell the end user whether the Kinect is plugged in or not, you can use this Kinect sensor chooser UI. And it's a WPF control that allows you to do that. And the Kinect sensor chooser has a Kinect change. And there's a Kinect sensor chooser class as well, which is confusing. But this class, the Kinect sensor chooser class, is a non-UI class, meaning I can use Kinect Sensor Chooser in a console application. I can use it in a Windows service. There's nothing UI specific about it. Kinect Sensor Chooser UI is WPF specific. But what Kinect Sensor Chooser does is it has an event called Kinect Change. And this will fire whenever our Kinect change. So if we're unplugging or replugging a Kinect in or adding a new Kinect, we can do things, for example, like turn off the old Kinect, or add it to our list of Kinects, or assign it to do a specific thing if it has this Kinect ID, and so on. Now, we're going to enable the depth stream, and we're going to enable skeleton stream, and we're going to do this to get that player information. And just like before, we're going to call all frames ready. And I won't talk about this because you all are so familiar with writable bitmaps, but we are going to create another writable bitmap. Now, same pattern. We're going to call our using, open the image frame to get the data, make sure we're checking for null, same as before. And now we have a formula. What we're going to do is get a list of bytes that's going to represent our image. And then we're going to use that write pixels that we showed the last time on color, but this time we're going to be doing it with depth data. Now, what's actually returned from the Kinect is this, the raw depth data. So we're going to go from raw depth data, that distance in pixels, to a bunch of colors. And that's what this formula does. So one is we know the number of pixels, and now we're going to just remember to write it out in a specific order. So blue, then green, then red. Now the way we're going to do this is our source to destination. And it's just a for loop that actually loops through both items. So our source is all the 320 by 240 numbers of distance in pixels. Our destination is that times 4 because we have to keep incrementing. So you'll see us in the color index actually jump 4 every time. So 0, 0, then 0, 1, and so on. Now, at this point, we do the formula, and this is the formula you all can reuse to get that player and that depth. Once we have this, now we're going to choose how to color it. So we are going to color anything under 900 millimeters, all blue. 255, max out blue, no green, no red. If we're between 900 and 2000, all green. And if we're greater than 2000, all red. So we are choosing how to do that. We return and use our writable bitmap and so on. But let's just show what this looks like. We have this UI right here, Kinect Sensor Chooser UI. And sorry, I'll just jump in here. And we see, well, if you see my hand, we're now less than 900 millimeters. We get to here, we're within here, and then 2000, I just disappear in this wall of red. Woo. All right, fun. OK, so we've shown the basics. Now, another thing we can do, and you do have to enable the skeleton stream, is actually tell the difference between pixels. And what if we wanted to color, if we know it's a person, color that person differently? So now we have, and I think this would just color, right now I'm not doing specific numbers for people, but now I know that that pixel represents a person. I don't know the location of their specific joints and so on, but I know it's a person and I can do something differently with that pixel. So if you see here, since we didn't have code, we could imagine doing different code to color player index of 2 a different color.
Out of camera, it thinks I'm data, but once it sees my skeleton, it could pop me into human recognition. So the player index, as Dan was bringing up, is at the tail end of those 16 bits of data that you're getting on the depth screen image. Just as the video image, it's 32 bytes, but the color, there were last 8 bits that weren't being used. On here, the last 3 bits are being used to give you a player index. So it's very efficient.
So I am going to uncomment this. And the only difference here is now instead of, you know, we're maxing out, now we're going to use the same color across all 3. And what that's going to do is give us shades of gray. And we use that, just a quick formula from saying, here's the max, here's the min, and then do just a simple formula. And just to show you, it's more of a scaling value now in terms of getting white to gray to darker gray. And the point is you can use this stuff to sort of do different colors here. And of course, order matters. So if we wanted that, because we are rewriting pixels here, all of these pixels will be ignored and all of the other pixels would have been ignored as well.
And you have several videos that you've done on every Kinect release on Coding4Fun, Channel 9, the videos that they can go through, and you have all this code and walkthroughs, and there's a lot of documentation on this. I know we're going really fast to get past the image processing stuff, to get to the cool demos, but a lot of this is already online. You'll see Dan's face there explaining it at a much slower pace.
Yeah, so we showed how to visualize distance data, and we can do different things. In fact, for one of our applications, we actually, and that we'll talk about later, we built a car that had a Kinect in the front and back. And what we could do then is visualize and actually have a regular color camera, but take parts of the depth camera that we wanted to overlay on top and say, hey, this is the closest object to you. And we actually know the distance of that object. So you know how far you are. And you can imagine that satellite example. You know how far you are. And you can actually see an image of that as well and use these in combination. OK. So skeletal tracking is one of the most common when you're thinking about enterprise applications or visualizing data because it acts on a level higher than just regular depth data. We wanted to teach you the image processing because it's always good to know. It's like eating vegetables, right? You have to eat vegetables. This is just dessert at this point, right? You've gotten through the hard part. So for skeletal tracking, we can have a maximum of 2 skeletons per Kinect. And there's 6 player proposals. Now, one thing you want to do is think about how you select skeletons. So if there were 6 people up here, the Kinect by default will choose kind of who's closest to the Kinect. You can choose different things. For example, like if you raise your hand, then you are the skeleton that should be tracked. But that's something that you need to, as a developer, set. And you can set the Kinect chooses skeletons equal to false, and then say, hey, based on this player index, what this person is doing, I want you to track this person. And there are 6 player proposals, and the API will always return 6. So the classic story was when we were first using the original port from the Xbox, I had on a debugger late at night. It's completely dark, so Microsoft turns their office lights off at 9 p.m., so you're just in darkness in a room. I'm on a debugger, and I hit a line, and I say, how many skeletons are in the room? And it says 6. There's 6 people, and I look around, and I'm like, 1? It will always return 6. And after I tinkled, I later said, OK, that's just how the API is currently written, is for 6 player proposals. So it's a good thing to know, and don't tinkle. Now, there are 2 modes for skeletal tracking. Default, which gives you all of the ones from seated, as well as the spine, hip center, and so on. And seated, which is specific. You can imagine the person that's working directly in front of while they're sitting down. And you don't have to be seated for seated. But when you turn on skeletal tracking seated, it's only going to give you those even if you're standing.
And that's relatively new, and it's one of the great new features on the 1.5 update, because there are 2 different interaction modalities, right? Xbox was very full body. You're very far away. But in IT, in a lot of perhaps more corporate environments, there are much more input modalities that would require somebody seated but simply moving in terms of large multidimensional data sets that way. So this is relatively new, but a lot of us are very excited that it's made its way into the SDK now.
Yeah. And so what actually is returned to us? An X, Y, and Z for each of those skeletal joints. So I can say how far away is the hand right, and say it is this X, Y, Z in terms of meters. So you can imagine, what's that, like 2 meters right there? In terms of a distance of x, y, z. And just remember, in terms of the positive and negative, the left will be negative from the Kinect, and the right will be positive. And then, of course, from the Kinect line, it's positive versus negative for those joints. So like you imagine, unless your foot is above the Kinect, it's going to be negative. Negative in joints. That hurt, actually. It's a little embarrassing. OK. Joint tracking and smoothing. So we have this data, and in real time, 30 frames per second, we're taking all of that depth data, and for you, just returning the positions of those skeletons. There are a number of things that can, for example, cause us not to be able to give you that data. And one of those is, if you see in the image, it being cut off. One, we can ask the skeleton whether it has clipped edges, and it'll tell us that the top is being clipped. So we will know that, and maybe we can tell the user, hey, maybe if it's their head being clipped, then we want the person to take a step back because they're getting cut off here. We can give that information to users. Inferred if, for example, like we have their wrist, but we can't see their hand, then we can infer the wrist is just here. But you can, for example, say how confident you are by saying if it's inferred, then we don't really know the location. If it's tracked, then we feel we do know the location.
We'd see that even with the robots. You have very tall people, when we'll get to them, very tall, and they're punching too high up. If you're punching over the Kinect, it can't see you. So these are all things you have to take into account when you're dealing with full body input.
Now, there can be times, because we are doing this very quickly, where the position of stuff doesn't translate correctly. So, for example, if I'm moving my hand very quickly, we might get data in 30 frames per second, where frame number 19 is a little off. And it really shouldn't be. And again, it's just the way the processing works. What we can do to control that is use transform smooth parameters, and that'll reduce the jitter, by using a double exponential smoothing algorithm. And just as a very simple algorithm, you can imagine a moving average algorithm where it says, I know this, I know this, I know this, I know this. Let's take the average. So if we have one here, the average would be here, not exactly here, because it's a moving average. This is a much more mathematical, and you can look at the exact example. And there's a number of people that do different smoothing types based on this data. But the point is that depending on how your application works, and we'll talk about some of the different ways, you may want to turn this on or off. So in a very fast application where I'm more like a game, I want this to feel responsive. In fact, if I turn on transform smoothing, which we'll show, it may feel laggy. But if I want something to feel like a cursor, I want it to feel smooth, and we'll show that in an application.
I think just the last thing on that is to put it in context of just how amazing and what the Kinect and the software are doing together. I mean, we've gone through already, it's a camera, but then it's shooting out an infrared pattern to see a three-dimensional view of what's going on. It's then figuring out what shapes are human versus what aren't human. And then on any given shape, it's saying this must be the proposed skeleton to make up that human shape. That is a tremendous amount of just insane math and calculations that are going on. To be doing that at 30 frames a second is crazy in itself. So smoothing.
But developers don't care. They say, make it faster. Come on.
I'm half a designer, so I really cared about that.
Okay.
That was impressive.
It is very cool that it all happened. See, I just discount it. People will be like, it kind of sucks when I do this. Don't do this.
And it's not smooth?
All right. So another thing to think about is how you're going to interact with the application. If I'm doing a yoga application, I think it's perfectly normal to have an application that causes me to move 2 meters in each direction. Maybe it's some sort of stretching application. But you can imagine I have a photo application where I'm dragging and dropping things, how annoying this would be. Right? They're going to kill you if you build this. So we have a way using our Coding4Fun. This is an open source extension for Kinect called a scale to that allows you to define the interaction zone for an application. And you can tweak this as you need. It's a great thing that people have been using in their apps. All right, so let's get to the demos. Now we can start having some fun instead of that image processing.
I know.
Okay, so I'm going to run this first, and we're going to show kind of what happens here. And with any luck, just take a step back. Oh, yeah. Well, let's just make this a little easier for me. Yeah. All right, so now we have skeletal dragging. What we're doing is taking an ellipse here, an ellipse here. These are just WPF items. And since this is drawing 30 frames per second, and of course an image, I am drawing it based on the position of where Kinect is telling me in the mapping it to color. Because remember, the skeleton returns everything in meters. What I want to do is take that skeleton position of this hand and then turn it into where it should go on the color point. So if you see here, and now we have also our skeleton stream does not have smoothing parameters. So what that means is if I try and get these things off my hand, and we'll see how fast they kind of go. Yeah, that's gorgeous. But you see every now and then, maybe if you look closely, we'll kind of lose one every now and then. So we'll see the difference by turning smooth parameters on and off.
Even without the smooth parameters, though, as you just showed, when 1.0 came out, or the betas, it was very jittery. So their default algorithms have already increased in quality tremendously, and then you can tack on smoothing now as well. But the 1.5 default algorithms are very nice.
Okay, so we showed the Kinect sensor, Kinect changed. We have our new sensor, things that we've shown before. The transform smooth parameters, you can play and tweak these as you need for your application. These are some that I personally like in terms of how they feel. You can also set seated. I'm not doing it in this application. But what I want to do is I'm going to uncomment so we can actually use these parameters. Now these parameters will be applied to how to actually calculate the position of that skeleton. And since we're using a couple features, we'll enable a couple different streams and so on. Now, the color image I'm going to skip since you all have seen that. Same pattern, skeleton frame, open the skeleton frame. We check for our null. Then we copy all our skeletons. And at this point, all skeletons is a list of 6. And what I want to do is get the tracked skeleton from those 6, get the one that we're actually tracking a person, and get the first one. So if it's null, return, meaning we don't have a skeleton. Now that we have a skeleton, if we just wanted to measure the distance, and we'll show this in another demo, measure the distance from the Kinect of the head position, we can do this. That position is an x, y, z value. Instead, what we want to do is take a skeleton point and map it to color so it maps directly where it should go. So then we have the, that's by using a color image point. And this is just an x, y representing of where that skeleton point should go. So now we have the x, y of all 3 points. And now I'm going to use a simple method that does set left and set top. And the reason we divide by 2 is if we told the Kinect to draw the image, it would draw it right here at the very top. Instead, what we wanted to do is draw it right in the middle. So take the distance and then put it divide by 2 so it's in the middle. If we wanted it on the far right, we could do that as well. But the point is, all we're doing is on that 30 frames per second, take those ellipses and draw them onto the screen. And I'll just show you nothing special about these. Regular ellipse, and an image. Now, we haven't talked about this, but this is the hover button. So we built a Coding4Fun hover button, and what that allows you to do is have a very common reusable button that has a sort of tap and hold functionality where you can hold it. You can control the interval. So this is 1.2 seconds. And you can imagine the image changing when we're active, meaning when we're spinning up. And you can reuse this control as well. And I'll show it in a second when we use our transform smooth. So I'm going to run this again. And now we said transform smooth. And you'll notice the behavior is definitely different. Now we are, it kind of almost feels like we have yo-yos. See how smooth that is? Oh, smooth. But this could be, depending on your application, this is great. Now, because we are mapping to color points, I can't get to that button, right? No matter how hard I try, it's mapping to a 640 by 480. There's no way for me to get to that button. We'll talk about how you can use the Coding4Fun object to scale this. But from here, you can see the differences in behaviors where it was very tracky, I'd say not using the algorithm for tracking. In this case, we see the difference when we do use the algorithm and sort of the smooth like butter appearance. OK, so if I want to click that button, let me jump back to our code. Here was where we're using the hand left and hand right and getting the x, y. I actually want to uncomment those. Actually, we'll leave the head just so it tracks where the head is. And for these joints, we actually want to use a scale position. So what scale position does is it scales a value. And we can choose how we want to scale those values and actually include a distance. So now if we took, for example, this default value of 1280 by 768, what that means is this is 0, 0. And as far as the Kinect can see me is 1280. And as far as the Kinect can see me is 768. By using some of these, you may not want this full interaction. What this allows me to do is actually scale the values using the max skeleton and max. And this defines my bounding box in an x and y coordinate system. And then we just set the values. So what this looks like, and again, what I've done is just set that scale position for the hands. And now they won't map to my current position. Instead, what I've defined is my bounding box is about kind of here to there, and I'm already off the screen just by going from this distance. So you can decide how far you want the people using your applications to go, and let's actually just try and show this button. We have a nice tap hold, and we have active or not active. And you can reuse this and make this faster. I'd say if you can get closer to 1 second in terms of the amount of latency required to tap this button, about 1.2 there, it just makes it for a better interaction zone.
Yeah, so again, Dan was scaling initially, scaling to the width of the image, and now he's scaling to the width of the screen when you want to be doing interactions. So.
Okay. Oh, actually, jump to you for
Studio?
Kinect Studio.
All right, so can you?
Yes, you are 7. Wait for it. Okay.
Nice. All right. So we've been working with Kinect, again, since it came out. One of the cool new tools that came out, and it's in the Microsoft SDKs. When you download BC program files, Microsoft SDKs, they have a tool for it, and it's called Kinect Studio. So to explain what Kinect Studio is, and it's relatively new, first let's start with the very basic Kinect project. This is one of the samples that comes from the SDK. It's a simple Explorer where you'd run it. It's basic Explorer. You can see, you do skeleton, depth. So again, this is one of the tools that comes in when you first download the Kinect SDK that you can go through, walk through the code, see what you're doing. It also shows the audio angles and stuff like that. Nothing, it's a good beginner sample, but we're simply using it here for demo. Now, as soon as you start building Kinect applications for a living, and you start doing this for a long time, one of the most frustrating things is that you have to code, and then you have to stand up and get out of your chair, and you have to come stand up like this, and everybody's walking around and laughing at you, and you have to wave, and you have to come back.
I forgot to turn this feature on, and it's the walk of shame back to the computer.
Really is. So when you start coding with Kinect professionally, there's a great new tool, and I'm a very big fan of it because I've done that developer walk of shame too many times here. It's called Kinect Studio. So what Kinect Studio does is it actually lets you record a lot of this data. So I've opened this guy up, and it's not going to work for
as admin.
No, I did not open it up, and that's a key feature. Kinect Studio needs to be opened at the same level of permissions as the application that you're developing. So this Kinect Explorer, which is running, I'm just going to close that out and restart it. So this instance of Visual Studio was started as administrator, as you see up there. It's not just a clever title. So if I run it up, if this application is opened as an administrator, Kinect Studio needs to be open as an administrator as well. If not, it won't see it. Now we do. So now what Kinect Studio does is it automatically pops up, and Kinect Studio is saying, hey, I see another process of Kinect running right now. Do you want me to connect to that? And basically start listening in on the line. So I can say, yes, please do. So here's Kinect Explorer, but you can see Kinect Studio. These windows here are from Kinect Studio. And it's basically saying, here's all the information that we're seeing from you, including this point cloud pixelation. Dan, do you want to stand there?
Are you recording?
Oh, okay, sure. Let me record. So it's showing you the stream live. This interface is visual heavy. But what if we're using a different interface, as we'll see before, where the application we're actually developing doesn't have an image processor because you're doing interactions in 3D space or whatever? Kinect Studio brings up possible windows that you can see in case your application's interface doesn't have one. But most importantly, it lets you start recording stuff.
2D space?
So you can start recording. Like right now, we're recording Dan. So, well, you're standing like a statue.
Yeah, okay. It is recording and moving. Okay, so yeah, that's wonderful.
There you go. So stop, go back to what you're doing on your own application.
And you can actually clip the beginning, say if the person doesn't move.
Exactly. So come in, you can start scrolling out through here. So it's recorded now, so you can continually play back. And in real time, while you're playing back, we're seeing that we can still see from multiple angles all the information that we recorded from down here. So that's really good. The Kinect, so I could stop this instance, get back, tweak my code, and as long as this guy is open, or I can save it and load it back later, it has, for professional Kinect developers, or if you're going to be coding for a long time, this one little tool has probably been my favorite tool in the toolbox because you can now record streams, save them, play them back, and explore them from multiple dimensions.
And this is great too for bugs. So for example, you know, we're going to have people in that are different sizes, different heights. We want to make sure our gestures work or our tap and hold. Something doesn't work, you have the recording. You can use that playback and make sure that your application is doing the right thing and be able to get at the color, depth, skeleton, the raw data, as well as the visualization of that data. And there is...
that is, I missed that.
Okay. Awesome.
Nice. Okay. Back to you.
Okay, so let's, okay, not me. Let's try me again.
And just press.
Okay.
Nice.
Hey. Okay, so another fun thing, and we've been showing, a lot of the API stuff. So how are we using Kinect? Microsoft, our team, people like to walk in and take things from your office. Anybody ever, in your cube, people take things, people take candy. People walk in when you don't want them to. So this was a picture from Reddit on a CEO that was left, and all of a sudden he finds that that employees have taken their picture in suits and in his office. So what things can you use to stop this from happening to your office using Kinect? And what we did was built a deterrent. So this is our deterrent to stop people from messing with us.
I got it.
So we'll set this up so you all can actually see and maybe get a little bit, yeah, something like that. We'll see how well, move this over, yeah. Okay, so
Dan always has the good candy in his office, so makes sense that he set this up.
And by candy, he means liquor. Okay, so we're going to see how well this actually balances. Not so great. I think maybe we'll try like this. How about there? That's it. Simple and easy enough.
We got to add these to the robot chassis so we can drive them around as needed.
All right, so I'll try and do a quick show of these. Well, you all saw me show it, so what I'm going to do is just run on our application, which is our turret. Ooh, actually, before I run it, I want to make sure to plug everything in. So we are using fidget controllers to do panning, and as well as a relay. And that relay we can do is programmatically, as a developer, tell something to turn on and off, like a gun. Oh, isn't this fun? Okay. So I'm going to make sure everything's plugged in. And with any luck.
So end of the night, you can leave your office. And
okay. So we have our camera here, and I'm just going to, hey, look, I'm in Dan's office. And there's a massive screen, and all of a sudden, hey, why is there a red dot on me? And
the gun's actually pivoting right now as you're...
Yeah, the gun is pivoting. I don't know if they can see the gun pivoting.
I don't think so, but it's very cool.
Okay, so the magic distance is 1.5 meters, and we'll show this maybe pivoting. We'll have Houston over there. But I'm going to get a little closer, and all of a sudden, yeah, jeez. Okay, get away. Do you want to stand away?
Yeah, sure, you can stand, sure.
I'll hold this up while we, oh God.
So they can see the pivots.
What are you going to do?
Oh, yeah, I'll
hold it up
this way.
All right, this is going to be awesome. So we have not been contacted by the military just yet.
This be like least effective soldiers aim enhancement.
Okay.
Hey, watch out.
Come on in. Yeah,
No, it's
come on
I'm
in.
good. I'm good. What's it? Is this yours?
Just rotate a little. Yeah. Just go in a little. Yeah, we see the gun moving. All right, just come on. Come on, take it. Take it like a man. Oh, yeah. I think I aimed that one. Okay. Okay, so the other fun part is because it is Kinect and we have these images, we can actually jump down to here and relive Rick going through, and actually I'll open this with image, let's see, photos, window photo viewer. So we can, just relive the agony, and then, wait for it. There we go. Oh, yes.
All right. That's going to be the default wallpaper once we release Windows 8.
I love Kinect. Okay, so we've shown how, I think I need to turn this off. It's really kind of into
Or
you.
at least stop.
Yeah, keeps tracking you. Okay, so some of the other things that you can reuse as a developer is our Kinect service. So because Kinect requires USB into a computer, if you have USB into a computer, you can then, using this, expose it either as a console app or a Windows service to expose Kinect data over the network. And that's using sockets. And we've built client libraries that make it really simple. It's 3 lines of code to be able to get color, depth, skeleton, and audio from the Kinect. So how could you imagine doing this? This is the Project Detroit that I mentioned that actually has Kinects in the front and back. And we're also using the Viper Smart Start alarm system. So if your car shakes and says, hey, somebody's close by, you can, say for example, you're in line at the coffee shop or a restaurant, you can imagine switching to your phone, because the phone's told you that the alarm's gone off. You can literally see what the car is seeing, the front and back, and listen. So you can listen to what people are saying in front of your car. And the other fun part is the car was built with a sound system that is external, so you can talk into your phone, and it will talk over to where your car is.
With voice masking.
With voice masking. So if you want to sound like really scary or sound like a woman,
either way,
you can do that. So it's kind of a great example. And another example that we've been using this for is Windows 8 applications, since the ability to talk to desktop isn't enabled. And I don't know the rules for the store. But certainly if, for example, you are talking via Kinect, you want to have a Kinect application on one laptop, and it's just reading data over the network, then a Windows 8 application, as long as it can read sockets, and we have our client library, which does all the work for you, it'll just work. For example, if you need to read it on the same machine, having a Metro style, it may not pass the store, but chances are maybe, depending on your need, not having a store and just having a demo application work. So it's something to keep in mind.
And there are examples when, yeah, there are definitely a lot of examples when you could do it that way. But
and this is available on connectservice.codeplex.com and connectturret.codeplex.com. OK, so face tracking. We've talked about Kinect color, skeleton, depth data. What face tracking allows you to do is have a data about your face, and actually have a collection of points that lets me know where different parts of your face are. Over 100 points that let me know parts of your face are. And for those of you that use Kinect, this is probably things that are brand new to 1.5, and we've even enhanced them with the 1.5.1 release that just went out 2 weeks ago.
yeah,
Or no, a week ago. A week ago for 1.5.1, I thought.
What?
Right between TechEd US and TechEd Europe. And it does give you a 2D and 3D mesh in points. So if you're building 3D models, you'll want the 3D points. If you're just looking to do something, for example, draw a lip or something on somebody, or draw a mustache, for example, in a fun application, you can just use the 2D. But if you want 3D, there's a number of things within here for 3D. And we'll talk about some of the head pose. But the animation units is also another very interesting example that uses the Candid 3 model. And what that allows you to do is actually build more like a mesh, a model of how your face is reacting, and have it appear, and even do things, for example, like know whether somebody's frowning or smiling. And it gives you a value of -1 to 1 to read those values. OK, so a head pose. This is sort of our hello world application, but we're going to use the ability to track your head and do different things. So imagine you're in a race game, or in a fighter jet, for example, in our example. Turning your head can give you the ability to see on the screen things that are different. So Kinect Forza does this today. So if you ever played Kinect Forza, it actually tracks where your head is and lets you look at the side mirror by just moving your head a little. So, and you can control the roll, which is kind of like how you're moving your head this way, yaw, which is what we're going to use, and then pitch. So you can imagine actually having ways to interact with your application where you're looking for somebody to say yes or no, for example, in your application. OK, let's show demos.
So we're going to probably have to fly through these last couple demos to get to the...
OK, I'll try and be nice and quick. So 2 things to show. So let's just, let me try and get our Kinect set up here. And this is just an image, and what I'm doing is based on the position of the image, and let's see if I can track my head I'm just going to move the image, and you can see, and when it gets to a certain angle, it can actually read your head, so it's just something to keep in mind. And chances are you don't want to force people to look 90 degrees diagonal, but it just shows a cool example, and you can imagine using your head as a way, almost as a cursor, to interact with it in an image. In this case, we're set on a plain field. But the way this works, very quickly, and let me just jump into our face rotation code, is I do a face tracker dot track. And what I need to do is pass in the color, the depth, and whatever skeleton I'm tracking. So all the data from that Kinect that we get in All Frames Ready, shove it into the face tracker. And if we are tracking successfully, all I want to do is get frame.rotation.y, and that is the value. And then we're going to do a translate transform, which is something in WPF that basically allows you to shift it. So nothing earth-shattering here. I pass in, do the facetracker.track, get that value, and then shift the image based on that. So one last thing that we'll show on this, Control-KU, Control-KC, is actually showing a mesh. And this here we can actually see a simple 3D model that just does line geometry, assuming everything works. And yeah, so I don't know if you all can see this, but it's on my face is this cool kind of model of 3D, and it shows me where all these points are. And I can do totally different things based on those points or build a 3D model. So
that's also new and also a very cool feature that we've been waiting for. The 2D as well as 3D, and the 3D mesh at that point, throwing it into DirectX or going through C++, there's just a lot of really cool things we start doing.
Okay, so let's get to sound.
Sure, we'll do. So we were talking about the microphone array. On sound position, there are two main things when you start looking at this, and we'll have a demo to show it. First off, there's a difference between the sound source angle and the beam angle. So the sound source angle is basically the Kinect saying, I am hearing that information from pretty much over here. So if I'm the Kinect, or the Kinect is facing out on you guys, we have a lot of people, somebody's speaking, the Kinect can say, I kind of heard it from over here. Okay, I heard this one from over here, right? And there's different levels of how much confidence it has on these types of things. You can then set to the Kinect, say, beam angle, set it to this particular area, because you might want to have be able to drown out a lot of other ambient noise from what's going on, or if you have multiple players. So these two in conjunction, it telling you what angle it heard that sound horizontally, and you being able to tell the Kinect, focus in specifically in this angle, provides a lot of input scenarios now that we didn't have with just a typical microphone that was bringing in dumb data in that way. This is just the stream that's coming in.
Okay.
So
speech recognition.
The next thing on speech recognition, again, seeing with this, there's multiple ways of doing grammar, because again, it comes with this and the speech abilities. If you download the SDK, you kind of get basic speech out of the box, but then you can also download speech Microsoft SDK to get some additional stuff. So on the basic side, it's as simple as doing it in code where you see var grammar equals new choices. This is the easy way to do it. Var grammar, you're going to create a new grammar. You're going to add the words that you want, and then you're good to go, right? You hook up to the events, and there's code samples for that. You can start getting more complex as you move from experimenting to kind of app ready and enterprise ready. You do have the ability of bringing it in from a XML file, and that's what that looks like over there, these rule equals ID confirmation. What you can see here is you're defining grammars there, but you have that one of property, scope public, example yes please. That one of means this is one of multiple ways of saying the above things. So you can start bubbling up things together. So yes, yeah, yep, okay. All those can be then aggregated into a primary command. So let's show a demo. Let's show a demo that kind of shows directions and grammar tied in together.
Sorry, give me 1 second here. And the other point to keep in mind on this is all those grammars. For example, if you were taking a phone number is a specific format. One, it's for a number of languages, but two, we've already built the grammar for you. So in that SDK on that slide was the sample grammars that you can reuse for your application. So rather than having to listen to how to figure out how somebody says a time, like 12:15 p.m., rather than building the grammar and structure, it's already built for you. Just reuse it.
Yeah, that's the best reason to use the SDKs from here. So we're going to start this up. What we have here is a tic-tac-toe sample. This sample also comes straight when you download the SDK. So if you see me, it has that X over my head. Oh, la, la, right on here.
Oh, I'm angelic. Wonderful.
The 0.
Oh,
so,
I wonder who's going to win.
So what's going on right here, the Kinect, it sees 2 different people. So the first person it popped in an X, the second skeleton it started tracking is a 0. And by using the sound angles and the beam directions, it's able to kind of try and isolate who's giving the command at any one time. So here's a game of tic-tac-toe. I'm ready, so if I say a number, I'm X, so I will say 3. 3.
I know that with the audio.
Oh, 3. 3. There we go.
7. 7.
We were having some problems with this one before.
7.
But I could be talking, and the Kinect is
7.
supposed to be listening to the direction that Dan's saying.
Well, isn't this a wonderful demo?
It is.
7. Let's go with 1.
There we go. 5. Square. 5.
Oh, this is painful.
Okay, so I think everybody knows how to play tic-tac-toe. But you can download the code, and you can see how it's supposed to be working when you're not wired up with mics.
Yeah, actually, I suggest using this application when you're not wired with mics. And one of the things to keep in mind, too, is to think about some of the ways that Xbox uses speech recognition. Is it has a keyword. In this application, it's continuously listening. So having a keyword that says Xbox, and then a microphone pops up. It gives you a visual cue that it is now listening. It has a little thing that shows you that it is listening. So you can visually see, hey, I know the application is listening. In this example, it's even hard to know, is it listening to me, is it not listening to me? So have an Xbox and then say play, or Xbox menu, and so on. So give that multimodal feedback, and that way it knows it has one word it's looking for, Xbox, and then you can have your specific grammar of numbers.
Many games are like that as you're getting ready to the next slide. The sample, the free sample, shows you the naive way. A lot of games, that's why I say connect, play video, or connect. The last slide, and we're going to fly through this one, is on joint orientation, simply because it's a brand new feature and it's very, very cool. From the beginning, we've always had the skeleton getting the joints, but we didn't have the orientations. Now we can cue the orientation. So let me just show you how that works. All right, I've finally gotten the hang of switching monitors. Oh, there we go. So basically, the best way to explain it is to show it if I don't fall off the stage. Here we have a skeleton. As soon as I pop in, and it gets me a lock, if you're using XNA or you're doing something with 3D, then basically it's not only my positions, but it's also my orientations in 3D space. You can do the robot with J.
Looking pretty good there, Rick.
Nice.
Yeah.
Check that out.
Is that the robot there?
There you go.
Yeah.
So this
geez.
is.
Oh, Rick!
Whoa.
Oh, God!
Look at my legs.
Oh!
It was very painful.
What happened?
Now, this is you know it's a new feature. What we're going to show now as we're moving into the robots. You have the interface?
Yeah, just the last thing that I was going to say on that is the cool part about joint orientation is you can imagine a motorcycle game where you're seeing where the joint orientation is. So it's not just the position, but that orientation.
Exactly.
And as Rick gets torn apart. Okay, so you've been with us for so long that we have some wonderful things. We do need 2 volunteers to do boxing robots. Clint, do you want to pick? Or Rick, why don't you go into the audience and pick? And I'm going to talk about this application while they get set up and they train you how to do this stuff, and you guys let me know when you need me.
Because you were here from
so,
like one of the very
boxing,
beginnings.
This is an open source application. You can take our code. And I just want to talk about while they're getting all this stuff going, one is we've taken that regular color image, and then we've applied a pixel shader to it. So we're giving a cool sort of Tron-esque, if you will, visualization. So we take the color image, we add a pixel shader, and it's now a cool pixel shader. Then we're using just Joint Cloud and WPF 3D to map all those squares being those positions of the skeletal joints. So we have a visualization of the skeletal joints. And then the Z-index, what you see as letter B there, that's actually, think of it almost like an overhead camera. That's the position. And in fact, when you move, what you do is you take one step forward. That little triangle will move forward and let you know the robot's moving forward. One step back, moves back. These wheels are omnidirectional wheels. So what that means is you can actually move left and right, and the robot will move left and right. And for those of you all that raised your hands that couldn't do this, we are right next to the Channel 9 Live area. I think we're doing afternoons like 1 to 2 each day, so please stop by and play. And do we want to give the, I think...
Yeah, do you want me to do a quick... Oh, you already explained it.
Yeah, we did the quick explanation. You all tell me when you're ready, and I'll jump on down and do this stuff. Okay, so let's do, how about these folks cheer for red? So let's hear for red. Red? Come on! Yeah,
yeah, as long as you...
All right, you folks, blue! Red, come on! All right.
So we are...
all right, we're going to do this? Okay, and you all signed your liability away, so any injuries
everybody
happen.
in the front audience.
All right, here we go.
Nice,
It's best of 3.
Throw right, throw right.
Punch, punch. All right, there we go. Stay on target.
Hey, what?
Yeah!
Oh, hold on, wait. One more. Rematch. 2 out of 3. 2 out of 3.
Yeah, red!
Okay, hold on. We got this one.
Let me know when you're ready.
Are you ready? Yeah. Hold on, I'm switching over control to his skeleton now. Okay, skeleton lock.
Come on.
Through left, 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 left. Hold on, break him up, watch out.
All right.
Wait, watch the crowd. Right, throw right, throw right. Right.
Punch right, keep punching right. Oh, that's a tactic. Run into the other person. That's brilliant.
Okay, break him up, back up. Left.
Yeah, left.
Left, 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 left. Oh! We're done here, but thank you very much. Thank you very much.
And you get a wonderful Kinect for Windows sensor.
We'll get you a picture of that.
Thank you.
Okay.
So just a couple things. Seth, you want to raise your hand? Seth is giving a talk as well on live demo introduction to the Kinect API. That's Hall A. That's Friday? Thursday? Thursday, 1:30 to 2:15. We do have the boxing bots in the expo hall. And, of course, make sure to complete your evaluation for us. There are wonderful prizes as well and just wonderful things. So thank you all for coming. Thank you for staying with us. Hopefully this was great for you, and we appreciate your time.